The E6B flight computer. The E6B flight computer, nicknamed the whiz wheel or prayer wheel, is a form of circular slide rule used in aviation and one of the very few analog calculating devices in widespread citation needed use in the 21st century. Basically, it's a slide rule which is made in a circular shape. They are usually made out of cardboard and plastic, or aluminium and plastic, with lettering and markings, either printed or engraved into the metal. The front side of the flight computer is a logarithmic slide rule that performs multiplication and division. As all slide rules, it can't do addition or subtraction. Throughout the wheel, unit names are marked, such as gallons, miles, kilometers, pounds, minutes and seconds at locations that correspond to the constants that are used when going from one unit to another in various calculations. Once the wheel is positioned to represent a certain fixed ratio, for example, pounds of fuel per hour, the rest of the wheel can be consulted to utilize that same ratio in a problem. The wheel on the back of the calculator is used for calculating the effects of wind on cruise flight. I think it might be a little tedious for anyone who is not interested in pilot or flight simulating games, so I'll just skip this part. I won't admit it's too complicated for a MATLAB simulation. The math behind it is really simple. Actually, for all slide rules, there are only two rules, shown on the PowerPoint. Moving the top scale to the right by a distance of log x, by matching the beginning of the top scale with the label x on the bottom, aligns each number y, at position log y on the top scale, with the number at position log x plus log y on the bottom scale. Because log x plus log y equal to log multiply x by y, this position on the bottom scale gives the product of x and y. For example, to calculate 3 times 2, the 1 on the top scale is moved to the 2 on the bottom scale. The answer, 6, is read off the bottom scale where 3 is on the top scale. In general, the 1 on the top is moved to a factor on the bottom, and the answer is read off the bottom where the other factor is on the top. Other features like switching kilometers to statute and nautical is much easier. Move the number of the kilometer to match the label km, and you find the correct statute and nautical on the label stat and naut, vice versa. Well, if those wooden-brained Americans accepted the metric system a century ago, how many troubles won't even exist? To make the matter worse, there are more units for fuel calculating: liters, gallons, US gallons, oil pounds, and even a US oil pounds. For the God's sake, they at least use minutes and seconds. Well, here comes the code. Pretty simple, huh? No, of course not that one. That's our goal, not only some simple math. Here comes the real code. For each picture, we need to create many vertical lines surrounding a circle with different radius and increase the line space by logarithm. There's some additional code which allows you to add labels. Just click where the label is and type it. You may change the number of labels by changing the number after G input and for. The practical realization of an E6B is very easy. Just print this, cut it and use a needle to fix it. I will show it in class. Nowadays, we have better computers based on transistors, but all pilots still take a E6B in every flight for emergency needs. When all electrical systems went down, you're still able to establish a traffic pattern instead of declaring a mayday. By the way, this only works for hydromechanical control systems but not for fly-by-wires, so don't imagine being a hero with your watch with E6B on a 747. But it is still useful in daily uses, especially for foreigners, for it can calculate the exchange rate easily. That's all, thank you.